Hello everyone and welcome to On the Spot STEM. Today we'll be recording JEE Advanced 2018 number 14. And the JEE stands for Joint Entrance Examination, and this is an exam held in India for engineering students. But a lot of the problems that show up on its mathematics section on the hardware end are also problems that could be viable to show up on AMCs and AIME. So the problem reads, let x is equal to 10 choose 1 squared plus 2 times 10 choose 2 squared plus 3 times 10 choose 3 squared plus all the way till 10 times 10 choose 10 squared, where 10 choose r and r is from the set 1, 2, all the way till 10, denote binomial coefficients. Then the value of 1 over 1430 times x is equal to, and we want to find this value. So first off, we notice that we can rewrite x in summation form as x is equal to the sum from 0 to 10 of I times 10 choose I squared. And we add the 0 because we have 1 through 10, but the expression kind of feels incomplete without 0, because we want essentially terms of the form I and then 10 minus I, because that will help us later. So we notice that x is equal to the summation, and we notice that we can rewrite this as the sum from 0 to 10 of I times 10 choose I times 10 choose 10 minus I. And this is because 10 choose I is equal to 10 choose I 10 minus I, where n choose k is equal to n choose n minus k, because choosing k objects from a group of n objects is the exact same thing as leaving those k objects from those n objects. So now with this definition, we can basically exploit symmetry, because we know that x is equal to 0 times 10 choose 0 squared plus 1 times 10 choose 1 squared, and all the way until 10 times 10 choose 10 squared. But this is also equal to, by symmetry, we have that x is equal to 10 times 10 choose 10 squared plus 9 times 10 choose 9 squared, all the way until 0 times 10 choose 0 squared. And what's special about this is because, as we established earlier, 10 choose I is equal to 10 choose 10 minus I. So that means 10 choose 0 squared is equal to 10 choose 10 squared. 10 choose 1 squared is equal to 10 choose 9 squared, and all the way and so on. So we can just add these two together, because we can combine these like terms. So we have 2x is equal to, we can factor out a 10 because we have I plus 10 minus I, and we have 10 choose 0 squared plus 10 choose 1 squared plus all the way until 10 choose 10 squared. And now all we have to do is compute this value. And this value is still very large, the value in the parentheses, because we're squaring these binomial coefficients. So we want to find a cleaner way to solve this. Well, as we did earlier, we're kind of motivated to write that 10 choose I squared is equal to 10 choose I times 10 choose 10 minus I. And basically from this, we can form a bijection, because let's consider we have 2 or 20 objects, okay? We have 20 objects here, and we want to choose 10 of them. So the number of ways to do that is equal to 20 choose 10. But if we separate this into 2, each of 10 objects, this is equivalent to choosing 0 objects from the first side and 10 from the other side, 1 from the first side and 9 from the second side, 2 from the first side and 8 from the second side, and all the way until we get 10 on the first side and 0 on the second side, because we're essentially going through all possible ways to choose 10 objects. So that's just equal to 10 choose 0 times 10 choose 10 plus 10 choose 1 times 10 choose 9 plus all the way until 10 choose 10 times 10 to the 0. And this is very nice because this is exactly the expression over here, as 10 to the 0 squared is equal to 10 to the 0 times 10 to the 10, and so on. So we can just replace the stuff in the parentheses with 20 to the 10. And going back, we have that 2x is equal to 10 times 20 to the 10. And x is equal to 5 times 20 to the 10. So what we don't want to do from here? Well, since we want to divide x by 1430 eventually, we can just expand this product as a product of a bunch of primes so that it will be much easier when dividing. So we have that 20 to the 10 is equal to 20 factorial over 10 factorial times 10 factorial. But this is also equal to 20 times 19 times 18. And I'm just going to leave out the dots because it's easier. And we go up till 11, but we don't have to write the 10 factorial because we know that it will cancel out with one of these. So we can cancel out the 10 factorial and just remain with 1 10 factorial in the denominator. And we want to simplify this expression. So 20 over 10 is 2, 18 over 9 is 2, 16 over 8 is 2, 14 over 7 is 2, 12 over 6 is 2, and then 5 times 3 is equal to 15, and 4 times 2 is equal to 8, which cancels out 3 of the 2's. So we're left with 20 to the 10 is equal to 2 times 19 times 2 times 17 times 13 times 11, which is equal to 2 squared times 19 times 17 times 13 times 11. And now we can just replace that with this. So we get x is equal to 5 times that expression, which is equal to 20 times 19 times 17 times 13 times 11. Now all it remains to do is to divide x by 1430, so we can do that on both sides. And notice that if we factor 1430 as our product of primes, it's equal to 5 times 2 times 11 times 13. The 11s and 13s cancel out. The 5 times 2 is equal to 10. 20 over 10 is equal to 2. And we're left with x over 1430 is equal to 2 times 19 times 17. 19 times 17 is equal to 18 squared minus 1, which is equal to 323. And thus, x is equal to 2 times 323, which is equal to 646. Going back to the problem, we see that we found x over 1430, which is 646. We look if there's anything else that we have to do. We don't have to do anything else. We can just fill this answer and move on. Thank you. If you enjoyed this video, please spread it to your friends or your family. And don't forget to like and subscribe if you enjoyed this video. And thank you.